We're currently situated at the airport at the lab of what we call TurboLab, which houses several different jet engines, and I think we even have a helicopter engine now next door. It's really a world-class laboratory where at a university we have actual jet engines that we can do research with. So because these engines are what we would call in a ground level facility, so they're not on a plane, they're not flying anywhere, they have to have special inlets put on the front of them so that they suck in air the correct way. So what we did here is we took the normal inlet and we kind of set that to the side, and we designed our own inlet so that we can do relevant research on an older engine that doesn't cost as much to run. To run this engine, we basically just have to pay for the fuel. If you go to kind of a dedicated engine test on an airplane or something, you're talking in the high hundred thousands to millions of dollars to go test that. And here we're looking at a couple $1,000s every time we run. So if we can prove the technology on the ground, we can feel really confident by the time we get to an actual test, on an actual airplane, that everything's going to go like we expect it to go. The more complicated piece of this is we're using a laser to measure things like the flow, velocity, and temperature and stuff like that, versus having physical probes inside the inlet.
We are developing the advanced measurement technique that is basically using the laser. So we are developing the laser diagnostics to apply the engine and the flow measurement for the engine performance.
When you put a physical probe in that area, you're actually changing the flow, because the flow has to hit that sensor and go around it, and in reality that wouldn't be there. So the laser, when you shine it through, it's just light, so it's not actually altering the flow in any way. So you get a real readout of what's actually happening, and that's really what we're trying to research and make sure that we can actually do that with a laser versus physical probes like people would normally use. But we have one more test left to go where we run the engine basically up to full power, and if that goes well, we're pretty much done. But looking forward, the inlet can be used for a ton of different things. One of the possibilities is putting small models inside of there and having the actual inlet act like a wind tunnel. So that's really what we're looking forward to in the future. And there's for sure a lot of other laser diagnostic techniques that can be used in this inlet.